Welcome, y'all. Back to some more geometry. Today we're talking about slope of lines. So let's kind of look at this right here. So a slope is it's the ratio of a vertical change over the horizontal change. So how things change. So in a line, hopefully you remember from algebra before, the line's moving either up or moving down or just side to side. That's a horrible side to side. There you go. It's moving. So there is a change. We're going, in this case, we're going up so much and then over so much. Up so much and over so much. That is what a slope is. It is the change of your your new spot minus your original spot. Your new x value minus your original x value. So this is the change in y, this is the change in x. So we're gonna just practice that. Now, so if you ever see when they ask you what is slope? Slope is a rate of change in horizontal and vertical rate of change in axis x and y. Now also is a good example. Rate of change is a key word, the key phrase, rate of change. FYI for a test. So find the slope of 5, -7, and 7, -14. So this was our first set of xy. So this is our x1, y1, and this is our second set. So it'd be x2, y2. All right, so we just plug these into this equation right here. So we got y2, -14, minus, and so that negative sign always is there, minus a -7, this is y, over x2, 7, minus x1, 5. So here we got minus a negative. What does that become? Positive. Yeah, so we got -14 plus 7. The opposite signs, they subtract, so that gives us a -7. Over 7 minus 5 gives us 2. So our final answer is -7 over 2. This is our slope right here. I want a 2 extra on that. There we go. Slope right here. Oh, that's horrible. Slope right here. There we go. Let's try that one more time. So you guys go ahead and try that. Pause it for a second. All right, hope you're back. You did it. We have the right answer. Let's see. So this is our x1, y1, and this is our x2, y2. So when I'm doing this, I have -1 minus a -3 over -2 minus a -7. These change signs, so positive, positive. So we got -1 plus 3 would be 2, and -2 plus 7, sorry, is 5. I think that's what I said, 5. So our final answer is 2 over 5, or 2/5. 2/5. So that's slope. We'll put that all together in the next section. Let's look at other things here. So what kind of slope does a horizontal line change? So I'm going to tell you right now, spoiler alert, it's 0. And let's see why. All horizontal slopes have what we call 0 slope. 0, you might see like that, or 0, or just 0. 0 slope. Let's see why. So this is kind of find the slope using mathematics right here. So we got x1, y1, x2, y2. So let's do the math behind that. So we'll do 4 our y2 minus our y1 over x2, 5 minus our x1. 4 minus 4 is 0. 5 plus 3 is 8. 0 divided by 8 is 0. Anything 0 divided by any number will always be 0. So we have to do it like that. That's why you always have 0 slope. Now that is a value. 0 is a value. So the equation for this is, what is the slope of this horizontal line? 0. Now vertical line is called undefined. Either it's called undefined, where you see it defined, or you might also see it as no slope. No slope. And we'll see why. Let's do this. So we're going to do this horizontal line. This would be our x1, y1. I said horizontal, vertical, my bad. And this would be our x2, y2 right here. So same concept, y2, so -4, minus our y1, 0, over x2, 2, minus x1, 2. We get -4 over here. We get 0 down here. And here's the thing. You cannot divide by 0. You cannot. -4 divided by 0 is what we call undefined. Undefined. Spell that, my gosh. Undefined or no slope. Those are two things you'll see it as, undefined or no slope. And you can never divide by 0 or else the world will explode. Not true, but if you try to do it in your calculator, it'll tell you error or no solution, or I don't know, it might blow up. All right, but let's just kind of talk about just slopes in general. How can you tell if a slope is positive, negative, 0, or undefined? How can you tell? Well, it's all about the direction it heads. We read left to right, so we look at slope going from the left side to the right side. So looking at this, what we consider a positive slope. Positive slopes are things that go in a positive direction, uphill, uphill. Positive y values. As you go from left to right, it's going uphill. This is a positive slope. Slope that's going downhill is what we call our negative slope. And of course, like we just said, horizontal lines is our 0 slope, and vertical lines, that's our undefined or no slope. Either one, undefined or no slope. So looking at this, doing black. No, I'm doing, yeah, we're doing black. What is a positive slope here? Well, the yellow, it's going uphill, pretty obvious. That's a positive slope. Is there another one? There is. Even though it's a slight change, this purple one is a positive slope. It's slightly changing. What is our negative slope here? It's orange. This is going downhill. This is our negative slope. Any other negatives? No. Blue, what we call our 0 slope. 0 slope, because it's staying flat. And red will be our no slope or undefined. Undefined slope. Now, you'll need this information here pretty soon. So, two lines, so as the theorem says, two non-vertical lines are parallel if and only if their slopes are equal. Now, again, this if and only if you remember from last chapter, if and only if means it's a biconditional statement. That means it work. I could flip this and it's still true. It works. Both things have to be true. They have to be non-vertical lines, and for them to be parallel, their slope has to be equal. If their slopes are equal, then they're two non-vertical parallel lines. So one proves the other one, and the other one proves the other one. They're back and forth. So here's an example of non-vertical lines. They are going up in the same direction. So if we were just counting points, this is the starting point for this one. It goes up 1 over 1 to the next intersection. Up 1 over 1 to the next intersection. So this is a slope of 1. This start with this one. This start right here goes up 1 over 1 to the next intersection. Up 1 over 1 to the next intersection. So that's a slope of 1. They have the exact same slope. So parallel lines will have the same slope always. Same slope always. That's what makes them parallel. Now, sometimes things that have the same slope could be the exact same line. They might give you two different equations, but they reduce them to the exact same equation. So they are the same line. And we'll talk about that. And that's actually a question on your test. But if the lines have different y-intercepts and the slopes are the same, they're parallel lines. Let's look at this other one right here. So slopes of perpendicular lines. Two non-vertical lines are perpendicular if and only if their slope equals -1. So here, if I multiply 1 times 1 right here, I get 1. Okay, so we'll look at that. But there's something else about this. They're what we call negative reciprocals. So let's look at this line. The slope, start with where's that intersection here? Right there. To the next intersection right there. So we go up 1, 2, 3, 4, and over 1. So this slope of this is 4 over 1. 4 or 4 over 1 is what we call it. Let's start with this one. Same intersection right there. It goes down 1, and we're going to this next intersection right here. Down 1 over 1, 2, 3. Oh, did I miscount that? 1, 2, 3, 4. 1, 2, 3, 4. There you go. 1, 1, 2, 3, 4. This should be up there. Let's fix that real quick. It is a little off. There we go. That makes more sense. Now it's going to the right spot. Must have moved it earlier before. All right. So starting the same spot right here. It goes down 1. So that's a negative 1 going down. Then it goes over 1, 2, 3, 4. This next intersection. That should be. All right. So look at these two slopes right here. If we were to multiply these two slopes, that's what I mean. The product of their slopes means the multiplication of the two slopes. If I take the first one, 4 over 1, times the next one, negative 1 over 4, I get, well, 4 times negative 1 is negative 4. 1 times 4 is 4. That reduces to be, y'all, negative 1 over 1 or just negative 1. Now, also what's different, let's look at the two slopes. So first, second. They're what we call negative reciprocals of each other. So perpendicular lines, their slopes are negative reciprocal. Reciprocal. Wow. I just had a little brain aneurysm trying to spell reciprocal. I don't know why. Reciprocal. My gosh. Negative reciprocals. Reciprocals. It's a C. My gosh. Okay, so they're negative reciprocals of each other, meaning if I take this original slope, 4 over 1, and I do a negative action to it, I change the sign. This becomes, for the negative action right here, becomes negative 4 over 1. And then if I do the reciprocal action to it, I flip it to be negative 1 over 4. These two are the same. So perpendicular lines are negative reciprocal to each other. They have negative reciprocal slopes to each other. Parallel lines have the same slope, so they're both the same slope right here. Negative reciprocals, same slope. Negative reciprocals, same slope. All right. That being said, I'm going to ask you some questions. Determine these lines, line AB. So they're saying line AB meaning the connection between these two lines. So we'll go from A to B right there. Let me extend it on this side so it doesn't look as awkward right there. Okay, that's line A, and let's look at line CD right here. C to D. We're gonna extend it this way as well. There you go. So are these lines parallel, perpendicular, or neither to each other? That's a good question. Now, from looking at it, it probably looks like they're the same. I mean, they're perpendiculars because they're intersecting almost like a right angle here. But let's double check that. So let's count the slope of here. So the slope here is down 1 to go from C to D, go down 1, and then you go over 1, 2, 3. So that's negative 1, we went down, and then 3. From B to A, so as we read left to right, we go up 1, 2, 3, 4, 5, 6. So we go 6, and then over 1, 2, 2. So we got negative 1 over 3, and then 6 over 2. Let's reduce that. It's 3 over 1. Is negative 1 over 3 a reciprocal to 3 over 1? Yes, they are. So it is parallel. If their slope was exactly the same, negative 1 over 3, negative 1 over 3, they'll be parallel. Neither will be any other version. If this was the first one was negative 1 over 3, and the other one was 7 over 2, there's no, this one reduced to 3 over 1. They're neither. They're neither parallel nor perpendicular. They just intersect, or there could be skewed lines too. But we are talking about coplanar lines, so they wouldn't be skewed. Any other kind of intersecting line will be what we call, in this case, would be neither, or they'll just be called intersecting lines. All right, to another example here. So determine that these two lines are line AB, line CD are parallel. So I'm gonna let you guys do this. Graph the points first, and then we can find the lines. All right, so we graphed these. So we got negative 3. A would be 3, 6. 1, 2, 3. 1, 2, 3, 4, 5, 6. There we go. That's our A line. Our B line will be negative 9, positive 2. 1, 2, 3, 4, 5, 6, 7, 8, 9. Negative 9, positive 2. 1, 2. Right there. All right. And then, let's go ahead and connect them as well while we're here. Switch that. We're going from there to there. Okay, I'm extending this way a little bit. There we go. That looks nice. All right, and our next one right here is CD. So we graph C. 1, 2, 3, 4, 5, 6. Ooh, 1, 2, 3, 4, 5. And then 4, 1, 2, 3, 4. Okay, so that's C. And D will be at 2, 3, 1, 2, 3. Right there. Oh, look at these two. Okay, oh, look at that. Eye test says what, y'all? They look parallel. Okay. Well, let's find their slopes. So let's say you don't have a graph like me. You're not able to just graph them and kind of count numbers. Just do your slope intercept. Do your slope formula. So let's take these two. So this is x1, y1, x2, y2. So we'll do 2 minus 6 over negative 9 minus 3. 2 minus 6 is negative 4. Negative 9 minus 3 is negative 12. So we get a positive 1 over 3. That reduces. And let's do this one over here. So this is x2, y2, x1, y1. So we'll do 3 minus 4 over 2 minus 5. 3 minus 4 is negative 1. 2 minus 5 is negative 3, which gives us a 1 over 3. They're the exact same. So they are parallel. Good, good, good. The same thing here. Graph a line that has a slope of 2 and contains 0.38. So has a slope of 2. So 3/8 is what matters. We start at 3. 1, 2, 3, 8. 1, 2, 3, 4, 5, 6, 7, 8. Now it has a slope of 2. That means from this point, I'll go up 2, and then it's a 2 over 1, and then over 1. So up 2 over 1. 2 over 1. So up 2, 1, 2 over 1. Now here's the thing. This is why I include this. On my graph, I'm out of space. But I can also do it backwards. I can also go down 2. I can go negative 2 as long as I go negative 1, because negative 2 over negative 1 reduces to be 2 over 1. So we can go down 2 as long as we go over 1. Down 2 over 1. And so on and so forth. So when I graph this line, it looks nice and pretty like that. That's our line. All right, y'all. Hopefully that kind of helps you through your homework. I'll catch you on a different day. Bye.